Okay, today we are going to work on multiplying and dividing rational expressions. And so we're going to be simplifying rational expressions and doing multiplication and division. But before we do that, I want to go back over factoring for you. I know you did some on the homework last night after the test, but I want to go over a couple of them with you just to make sure you're sure what to do. That way you're ready for it also. So I've got three quadratic functions here, quadratic expressions that I want to factor. So I want to go back over how to do that factoring before we get started. So first of all, when I'm factoring, a simple one where I have the coefficient of x squared is 1. Then we are going to find the factors of negative 14, the last term. Then when I add them together, I get the middle term. So the factors of 14, then when I subtract them are 5, would be 7, negative 7 and positive 2, so we get x minus 7 and x plus 2. So that would be the factorization for number 1. Number 2 says 2x squared plus 7x minus 15. Now we can do this two ways. Hopefully you can factor it without having to use any special techniques, that you can see the combinations that would work. So if I do it with, if I can see what's happening, it makes it a lot easier and it can go a lot faster for you. If you are not able to see it and you have to use a special method, which I'll show you, the method that we use is called slide and divide. I'll show you how to use that method in just a moment. First of all, since it only has 2x squared here, I know that this can only be 2x and this one has to be x for me to multiply them together. And so then what I'm looking for is to be able to do combinations of when I multiply these two terms together and these two terms together so that I get 7x. So when I take the factors of negative 15 and I put them in this second spot and the last spot here, then I should end up with positive 7 when I do that. So I think about the factors of 15. So the factors of 15 are 3 and 5, or 1 and 15. So I want to think about how I can use one of those factors, multiply 2 by 1, and subtract 1 times the other one and get positive 7. So to do that, in this case, I would have a positive 5 here. So you get 2 times 5 is 10, and negative 3 here. So I have a negative 10x minus 3x is a positive 7x. Now, the other way you can do this is what we call a slide and divide method. And with the slide and divide method, the first thing we're going to do is, if you remember, this is ax squared plus bx plus c. So the first thing I'm going to do is multiply a times c together. So when I do that, I get x squared plus 7x minus 30. So I'm multiplying 2 times negative 15. And then I'm going to factor this now. So now it looks more like what I had in number 1. So I want the factors of negative 30 that I get, when I combine them I get 7. And in that case it's going to be x plus 10 and x minus 3. Then after I do that factorization, so we do a times c, then we factor. And then we're going to divide the coefficients by our letter a. So in other words, we're going to divide by 2. So we're going to divide 10 by 2 and negative 3 by 2. So we'll go ahead and simplify them. So we get x plus 5 and x minus 3 halves. So then the slide part of this then, with the slide divide, says that I'm going to take any denominators I have here, like this one, I have a denominator here is 1. When I slide that over here, I just have 1x. So I'm going to take this 2 and slide it to there. So that gives me x plus 5 times 2x minus 3. So just a little reminder about the slide divide method, and I'm actually going to do it one more time, a little quicker this time, but do it with this problem here, 6x squared plus 13x minus 5. So when I do the slide divide here, I multiply 6 times negative 5, I get x squared plus 13x minus 30. So I factor again. The factors of negative 30 that give me 13 are going to be positive 15 and negative 2. 15 minus 2 is 13. And then I'm going to divide by 6. Divide both these numbers by 6 then. So that gives me x plus, and so I'm going to divide both of these by 3, so I get 5 over 2. And divide these both by 2, and I get 1/3. So then I take these denominators, and I'm going to slide them to in front of the x. So the factorization here would be 2x plus 5 times 3x minus 1. Like I said, hopefully you can factor without using that slide and divide method, but if you need it for situations where you have a coefficient of x squared, then go ahead and use it. Okay, let's get into the lesson now. And it took a couple minutes, and let's go ahead and get moving here. So in lesson 8.1, which we're actually going to do on Monday, we're going to work with what's called inverse variation functions. And another name for those is rational expressions. A rational expression is a quotient of two polynomials. So you can see here we have these fractions or rational expressions, and they all have polynomials in the numerator and in the denominator. So you can't have any exponentials in them. It can only be polynomials, like a constant like 10, linear ones like these, or quadratic, or they could be cubic or larger than that. The first thing that concerns us when we have rational expressions is the fact that we cannot divide by 0. So our first concern is, okay, what's going to cause the denominator equal to 0? And so what we have to do is, when we're talking about domain, is that we can't let the domain be a value to where the denominator is going to be 0. So here they want us to simplify rational expressions, and they want us to identify any values where it's undefined. In other words, when is the denominator going to be equal to 0? So our first one here is one where we're just going to simplify the constants and the variables. So 10 over 6 is going to reduce to 5/3. And x to the 8th over x to the 4th, I can cancel or cross out 4 of the x's. So it gives me x to the 4th in the numerator. Now, when I'm going to find my, where it's undefined, I'm looking back at my original denominator. And what makes that equal to 0? And if all there is an x there, it's just plainly, or x to the raise to some power, it's just plainly that x cannot equal 0. And we'll write it that way, that x cannot equal a certain number. Okay? Look at letter B here. And here we're talking about doing some factoring then. So in this case, they want us to simplify and identify where the values are undefined. So the first thing that we're going to do when we're trying to simplify is, if we can, we want to factor. So I'm going to go ahead and factor this first of all. The numerator, that would be x plus 2 times x minus 1. And the denominator, x plus 3 and x minus 1. So you can see that after I factored this, that I actually have common terms in there, or common factors in the numerator and denominator. So you can only cancel, okay, when you have common factors. So when I started here in my original problem, some of you will come along and say, oh, well, I can cross those out. And actually you can't, The only time you can cancel is when there's multiplication going on, which is when we have factors. So since x minus 1 and x minus 1 are common factors, are exactly the same, then I can go ahead and cancel those both. And so my final answer here is going to be then that my final answer will be x plus 2 over x plus 3. Now, when I talk about where it's undefined, I have to go back and look at the original denominator before I cancel. So I have to look at both of these factors here for where it's undefined. So I'm going to say then that x cannot equal positive 1 for the x minus 1 factor and negative 3 for the x plus 3 factor. So 1 and negative 3. So to simplify the expressions, we're going to factor, cancel the like terms or common factors, and then when I tell where it's undefined, I have to go back to the original problem where it's factored before I cancel to be able to simplify it. So this would be my answer here, x plus 2 over x plus 3, and x cannot equal 1 or negative 3. Here we're going to look at factoring out negative 1, which sometimes we end up with common factors that are opposites, and when that happens, we're going to take a negative 1 out of that factor so that it changes it. So, for instance, let's say I had a factor of x minus 3. If I factored out negative 1, in other words, if I put a negative 1 here in front, that's going to change both of these signs. It's going to make the x negative and the 3 positive. Or if I had something the opposite, like if I had 3 minus x, and I factor out a negative 1, it's going to change those signs. So it would make the x positive and the 3 negative. So anytime you have a situation like these two where you would have opposites or factors that are look-alike, but their signs are the opposite, we can factor out negative 1. And we'll do that here with this problem. So in the numerator, we're going to factor out the greatest common factor. There's only 2 terms here. So the first thing I want to look for is the greatest common factor. They both have an x, so I'll take out x, and I'm left with 4 minus x. In the denominator, x squared minus 2x minus 8. I can factor that. We have x minus 4 and x plus 2. So if you notice, now I have x minus 4 in the denominator and 4 minus x in the numerator. So these are opposites, 4 minus x and x minus 4. So what I'm going to do then is I'm going to take the 4 minus x and I'm going to factor out negative 1 so that it changes that 4 minus x to an x minus 4, just like we did here. So when I take out negative 1, I'll put the negative 1 out front, then my x. Now I have x minus 4. So because I factored out negative 1, this 4 minus x becomes x minus 4. Their signs switch. Just like when we multiply by negative 1, we change all the signs. When we factor out negative 1, we change all the signs. So in the numerator, we have x minus 4, or the denominator, x minus 4 and x plus 2. And now I can cancel these x minus 4s, and then my answer will be negative x over x plus 2. And once again, they want us to identify where it's undefined. So let's move this. So I identify where it's undefined, and so x cannot equal, and once again I go back to the original factoring I did up here, so x cannot equal 4 or -2, or -2 and 4. So when you end up with factors that look similar, but they're opposites, then we're going to factor out a -1. Multiplying rational expressions. When we're multiplying rational expressions, the first thing we want to do is we're going to go ahead and multiply everything we can if it looks like this where we have monomials. Okay, we'll go ahead and multiply. But anytime I have binomials or trinomials, I want to look to factor before I do the multiplication, and I'll show you that in just a moment. So for letter A, because I'm just multiplying with monomials here, I'm going to go ahead and do the multiplication to start. So I'm going to multiply my numbers together. 3 times 10 is 30. X to the 5th times x cubed is x to the 8th. Remember, we're adding the exponents when we multiply the same base. In the denominator, y cubed times y to the 4th is y to the 7th. In the denominator, 2 times 9 is 18. X cubed times x squared is x to the 5th. And y to the 7th times y to the 5th is y to the 12th. So I've made it so I only have one fraction bar. And that will help me simplify these a little bit more. So I look at my numbers, 30 and 18. So what do 30 and 18 have in common? They have 6 in common. So then I can divide them both by 6. So I'll get 5 over 3. And then I have, look at my x's. X to the 8th over x to the 5th simplifies to x cubed. And y to the 7th over the y to the 12th. Oh, the y to the 12th is larger, so I actually need to move that up and make my fraction bar bigger, because I'm going to have 5x cubed in the numerator and 3y to the 5th power in the denominator. So if the one in the denominator is bigger, I'm going to subtract the numerator from it, and then I'll put my answer in the denominator, because I would rather work with positive exponents than negative ones. So anytime you have just monomials that are multiplying, just go ahead and do the multiplication first, and then simplify. You could cancel as you go. You know, I could start here and cancel, work with these x's and reduce this x to the 5th to x squared here, because with the x to the 5th over x cubed. I could do that here also. You can do that if you want. I think it's just easier to simplify it, so I only have one x in the numerator and one y in the numerator, and same with the denominator. So whichever way gets you to the right answer is okay doing it. Now, in letter B, when we're multiplying, the first thing that we want to do is we want to factor before we do anything else. And I want to do that because it allows me to write it as a single fraction bar then, just like I did here. But also, I have my factors, so if I can cancel any like factors, it allows me to do that so that it simplifies it quicker. Because if I multiply this all out, it's just going to get really big and really ugly fast. So we want a factor first of all. X minus 3, linear factor, can't do anything with that, so I'm going to write it as x minus 3. But I am going to put it in parentheses because it is now a factor, because x plus 5 is also a factor. And I want one fraction bar, so I'm going to write those as being multiplied together so that I can make just one single fraction bar. And now in the denominator I'm going to factor. So I first look at the 4x plus 20. Okay? It's a linear, and I have to see, okay, do they have anything in common? I got two terms here, do they have anything in common? And yes, they do. They both have a 4. So I take the 4 out, and I have x plus 5. Then I look over here at my next one, x squared minus 9. Okay? These don't have anything in common, but these are the difference of two squares. And so if you remember, difference of two squares, I have x squared minus a squared, and that's x plus a times x minus a. Right? We did difference of two squares a lot in chapter 5, so x squared minus 9 is going to be x plus 3 times x minus 3. So now I have factors in the numerator and the denominator. So one of the things to remember is, before I start factoring this, is that we have a little glitch here that we need to pay attention to, and if you don't do it just right, you're going to end up with the wrong answer. So watch how this works. That a little reminder that when I cancel, here I have x minus 3 over x minus 3. So remember, we're actually dividing. So if I divide x minus 3 by x minus 3, I get 1. So when I cancel these out, I now have 1 in the numerator and 1 in the denominator where those were at. Here I have an x plus 5 and I have an x plus 5 here. When I cancel those out, I'm actually dividing by x plus 5, which means I have a 1 in the numerator here, 1 in the denominator here. And what happens is, if you don't do that cancelization with the 1's here, then what happens is you think, oh, there's no numerator. But actually there is, because 1 times 1 gives me 1 in the numerator. And now in the denominator I have 4 times 1 times x plus 3 times 1. So my final answer here, yeah, you probably could leave it this way. Sometimes when it's really difficult, this one's a pretty easy one. So I would multiply it out to 4x plus 12. And in these problems it says assume that all expressions are defined, so you don't need to say that x cannot equal certain numbers, because we're going to end up with a whole bunch of them. Here we would end up with -5, -3, and +3. So in this case, this would be my answer. 1 over 4x plus 12. Okay. So there's the multiplying of them. We want to factor, so I have one single fraction bar, so then I can go ahead and look for common factors that I can cancel. Now the next one is dividing. Dividing is the same as multiplying. The only difference is that when I'm dividing by a fraction, you guys know the first thing we do is copy, change, and flip, because we need to multiply by the reciprocal. So if we look at the first one here, all right, once again we're working with monomials, but it says dividing here. We're dividing instead of multiplying. So my first step is going to be rewrite. I'm going to rewrite the first fraction, change the sign to multiplication, and then take the reciprocal. Take the reciprocal of the second fraction. Now, one thing is here is I want you to think about. If I go ahead and divide in this case, right, or multiply 5 and 8 and 8 and 15, what happens all of a sudden is I got a really big number here with 8 and 15, and it might not be as easy to divide it. So you might want to try a little different technique, and that might be to do this. Instead of actually multiplying them, write them as 5 times 8 times x to the 4th times y to the 5th. Now I know I didn't do that in the first one, the previous example, but this might help you when your numbers are a lot bigger. So down here I get 8 times 15 times x squared times y squared. So now instead of multiplying this out, because 8 times 15 is 120, a little bit harder to work with, but now I can actually see that I can just cancel the 8's, and I have a 1 in each of those spots. Then 5 goes into 15 3 times. Oops, it doesn't like that one, so go back here. So we have 3 here. X to the 4th over x squared will give me an x squared. Y to the 5th over y squared would give me y cubed. So I have in the numerator then, we have 1 times 1. We're going to end up with x squared in the numerator. And y cubed. X to the 4th over x squared is x squared. Y to the 5th over y squared is y cubed. And then I'm going to have 3 in the denominator. And that'll be my answer. X squared y cubed over 3. So same thing then here. When you're multiplying with, or I'm dividing, the first thing I'm going to do is to copy, change, and flip. So we've got x to the 4th minus 9x squared. And this one's, we're really going to have to take our time doing it because we're going to end up with a lot of factors. Over x squared minus 4x plus 3 times, take the reciprocal, x squared minus 16 over x to the 4th plus 2x cubed minus 8x squared. Now this one's going to get really long, so we're going to have to take our time in doing it. Alright, so first of all, we look at the first one here, upper left. Alright, what do they have in common? Okay. They have x squared in common. Alright, so I have x squared. What do I have left? X squared minus 9. Okay. Hopefully you can see that that's something that's also factorable. Over here we have x squared minus 16. Okay. X plus 4, x minus 4. Difference of 2 squares. In the denominator, okay, what are the factors of 3 that add up to 4? So that's going to be x minus 1, x minus 3. Over here we got another big one, all right, because we got to the 4th power. X cubed, x squared. So these all have an x squared in common. So I'm going to first pull out x squared, and that'll leave me with x squared plus 2x minus 8. So when I look at this, yep, I factored it some, but I still have 2 parts that have this part here and this part here that are factorable because they're still quadratics. So I'm going to have to go one more step here. Now, when you do this other step, one of the things I want you to notice is that I have an x squared here and an x squared here. Whenever I have just a monomial in the middle, I'm going to move it to the front, if I can see that, so that when I move it to the front there, it kind of keeps those together. So we've got x squared minus 9 is x plus 3, x minus 3, then I have the x plus 4, and x minus 4. Draw my fraction bar. This x squared, I'm going to move it to the front. Okay, that's going to be nice because those I can cancel. Still have our x minus 1 and x minus 3. And then we have x plus 4 and x minus 2. So there's a lot of factors there. If you take your time, work slowly through it, you can get them. Now I do my canceling, all right? My common factors. X squared, okay? So I cancel those, I have 1. All right? Here's an x plus 3, don't have any of them. X minus 3, got that. So factor that, cancel, put in 1. X plus 4, x plus 4. All right, cross those out, I got a 1. So in the numerator now, I have 1 times x plus 3 times 1 times 1 times x minus 4. So x plus 3 times x minus 4. My fraction bar. Then in the denominator, what do I have? 1 times x minus 1 times 1 times 1 times x minus 2. So x minus 1 times x minus 2. And I am going to allow you to leave your answer like that. You do not have to multiply them out. One thing is because that problem is so long, takes a while to get to the end, you're going to want to just leave it that way just for simplification purposes for you. Alright? So we have one more example to do. Alright, we're still going to work with factoring and like that. This has been a lot. I think you can do it. Just take your time, make sure you look at the examples. This will be up on Facebook so you can access it. So go ahead and use it there. If you need to review it, if you need a specific spot. All right? Well, let's look at the last one. So before we go to the last one, let's go back for a second. And anytime it says identify x values for which the expression is undefined, you've got to tell, at the end, you've got to say x cannot equal these. But when you're doing multiplication and division, most of the time they're going to tell you